Hey guys, Mr. Grahn here. This is 6.1 polygon angle sum theorems. In this video, we are going to talk about exterior angles of polygons. So, first off, what is the difference between interior and exterior? When we say interior and exterior, interior literally means it's on the inside of the polygon, and exterior means it's on the outside. So, for the exterior angles, we have to sort of extend the sides a little bit. Right? And then it's all of these angles that would be on the exterior if we extend all of those sides out like that. Those are all the exterior angles. So for a lot of this, we are going to be talking about regular polygons. And what a regular polygon means is that all the sides are congruent and all the angles are congruent, right? So like your equilateral triangle is a regular triangle. A square is a regular quadrilateral. A pentagon, a regular pentagon, right? All 5 sides are equal, all 5 angle measurements are equal, that sort of thing. We represent the letter n represents the number of sides in a polygon. So if we say a polygon and n equals 5, we're talking about a pentagon because it has 5 sides as well as 5 angles, interior angles. All right, so speaking of exterior angles, in any polygon, the exterior angles always add up to 360, no matter how many sides. So whether it's a triangle, a quadrilateral, a pentagon, whatever it is, all of those exterior angles, so all of these, if we add up all of them, they're going to always add up to 360 degrees. All right, what that means is for each exterior angle, right, for regular polygons, that is, the way that we can figure out what what each of them equals is if we do 360 divided by the number of sides and the number of angles, right? So 360 over n, that tells us what the measurement of each exterior angle is. So for example, if I wanted to know this exterior angle, right, I would count up the sides 1, 2, 3, 4, 5, 6, 7, and I would do 360 divided by 7, and that gives me the measure of this exterior angle. Okay, so some examples. What is the sum of the exterior angles of a pentagon, right? Well, pentagon means n equals 5. Well, in this case, kind of a trick question because the sum, our rule is for exterior angles that they always add up to 360. So this one, what is the sum of exterior angles of a pentagon? 360 degrees automatically. Now for this one, a little bit different. What is the measure of each exterior angle? So key word there. Now we're talking about each one of a regular octagon. Well, we need to know that n is equal to 8 for an octagon, right? And all we have to do is 360 divided by 8, and that is, what is that? 45, that's right, because divided by 4 would be 90, so it'd be half of that, so 45 degrees. So if we think about a regular octagon, so like a stop sign, right? What is the measure of each of these exterior angles right here? And that measurement is 45 degrees, if I drew it accurately. All right, next one. What is the sum of the exterior angles of a 24gon, meaning that n is equal to 24, and that means it is a shape with 24 sides. Well, again, kind of a trick question. The sum of exterior angles is always 360 degrees. All right, next one. What is the measure of each exterior angle of a regular 16gon, meaning that this has 16 sides? Well, again, if we're talking about each exterior angle, right, each individual one, we would take 360 degrees, and there's going to be 16 of those angles to split it between. So 360 divided by 16, 22.5 degrees. So if you imagine a 16 gon, I'm not going to draw it out, but imagine that there are 16 sides here, right? And I keep going. The exterior angle for each one of these is about 22.5 degrees. All right, a couple of examples solving. Now we don't have a regular polygon here, but that's all right. It's still going to add up to 360. So we have 70 degrees used up here, 60 here, 65, 40, and our last exterior angle is here at x. All I have to do is subtract all of these things from 360. So I can either add it all up and subtract them, or I can just subtract them individually. It really doesn't matter. And what would that give us? This would be 100, so we're down to 260, 195, 125, I think is what we have left. Let me double check. Yeah, 125. All right, and then last one. So now we've got a little bit of algebra involved. Instead of just finding one angle, we are going to figure out what x is, and then use that to figure out angle A. Now I know all of these add up to 360, right? So I could say that the sum of all of these, so I've got an x, I've got a 2x, right? I'm going to kind of cross them off as I go. I've got another 2x, I've got a 4x, and I've got a 3x, that all of these add up to equal 360 degrees. Well, now we've done algebra like this before. There's a lot of different terms with x, but all we have to do is combine our like terms and solve. So we've got 1, 2, 3, 4, 5, 9, 12x if we add all of those together. And so now I just have to divide both sides by 12. And I get that x is equal to 30. All right, we solve for x. Now we need to know what angle A is. A is equal to 2x, so for angle A, it's just going to be 2 times 30, which is 60.